we have done all the questions of for 1 mark. Now we are going with 2 marks question. So question number 14, define the terms sample space and event associated with random experiment. So this is from chapter 14. First, sample space. Sample space means the totality of all possible outcome of an experiment is called the sample space of the experiment. All right. So for this, what is the meaning of this? What is the meaning of this definition? Is that, let's say you have a die. You know die, right? The die means not that which we are going to die or where we are going to lose our breath, but die here means that Ludo, okay, Ludo, that which we play, that is called die. So in a die, in one die there are how many numbers? 6, right? 1, 2, 3, 4, 5, 6. So this all the numbers that is this all the number is being contained by one die. Okay, one die. This all the numbers, if these all the numbers are included, not 1, not 2, not 3, not 4, not 5, but all the numbers, all these numbers are included, then we call that as a what? Sample space. All right, then sample space. This is only example, okay, but definition we have to write like this. And event. What is the meaning of event? Any component of a sample space is called an event. That means, just now I wrote already, when we throw a die, okay, there will be how many sample space? 6, right? 1, 2, 3, 4, 5, 6. All right, 1, 2, 3, 4, 5, 6. So out of these 6, any component, maybe 1, maybe 2, maybe 3, maybe 4, maybe 5, maybe 6, any one component or any component of these is called an event. Okay, it's called an event. All right. Next, question number 15. This is from chapter 1. Okay, this is also 2 mark question. What does this mean? It asks if x belongs to, this is belongs to, okay, epsilon. This letter is epsilon and this indicates as belongs to. If x belongs to real number, prove that modulus of minus x is equal to modulus of x. Modulus of minus x equal to modulus of x. We have to understand that the work of modulus is to what? Make a number, any type of number, a positive number. Okay, any type, maybe minus or maybe plus. The work of this modulus is to make that number as what? Positive number. And the number which comes out after the modulus, means after getting inside the modulus, the number which comes out, that is called as absolute value. Alright, so we have to prove this. This is also 2 mark. If for the first case, okay, whenever we solve modulus, there will be 3 cases. Okay, always there will be 3 cases. Let's not forget. First case will be x equal to 0. Okay, and the second case will be x is greater than 0, and the third case will be x is less than 0. Right, x is less than 0. If I take x equal to 0, then it is true. It is always true, because what happens? Let's say minus 0. Okay, this side. Then I get 0, because there is no any 0 which consists of minus symbol. Okay, so the value of minus 0 will be 0. If I put here, now the second one is not, there is no minus. Okay, if I put plus 0, right, then I get here again 0, right? So then when I put maybe plus 0 or minus 0, I get the same answer. Because of that, it is written here. Clearly the equation holds for x equal to 0. X equal to 0 means it is true. Then what happens if x is not equal to 0? What happens if x is not equal to 0? Then let's see. So let's say when x is not equal to 0, when x is not equal to 0, then we are going to get what? 2 number, okay, 2 number. That will be what? Before I have already told you, the work of modulus is to make the number positive, right? So if this is not equal to 0, right, let's say it's not equal to 0, that means, or let's say it is less than 0. Okay, it is less than 0, then what we get? Let's see. If it is less than 0, then it will be what? Let's take the number as -2, right? So -2 will be what? Will be -2. And whenever this number comes out, it will comes in two ways. Okay, one will be positive and one will be negative. According to the formula of modulus, one will come as minus, and the another will what? For another, what will happen? We have to remove this minus. In order to remove this minus, we are going to multiply with minus. That is -2 becomes +2. So the first one is minus x, and second one is we are removing minus. Okay, then minus is equal to plus. Okay, so that comes 1. That means the greater of minus x and minus x. Now what you have to know, that after we put inside the modulus, whatever the absolute value we get, one is we get minus and one will be getting plus, right? Out of these two, which one is greater? -2 is greater or +2 is greater? +2 is greater, right? That means in modulus we have to take the value which is bigger. Okay, which is bigger. That's why it says the greater of minus x and minus x. So out of these two, which will be greater? Minus x, right? So minus x and minus x. This is also x, this is also x. The thing is that we are putting here minus, that's why here comes minus, and one will become positive, that's why here is minus. So out of this minus and this plus, out of these two, which we are going to take? We are going to take the bigger one, positive one we are going to take. Okay, after that what happens? Minus comes as it is, minus into minus becomes plus. Then next what happens? This one we are going to write first and this one we are going to write second. Exchanging, it doesn't matter. Okay, it doesn't matter. So at last what we get? We get modulus of x. Why? We should know that if I put here x or if I put here 2, then when it comes out, it will come minus and plus. Okay, minus and plus, it will come together. Okay, minus and plus will be together. So plus, if I put plus also, I'll get minus and plus. If I put minus also, I get what? Minus and plus. So inside the modulus, if it is minus also, we get same number, minus and plus. If it is plus also, we get same number, minus and plus. That is what it is going. It is asking us to show. Just look here now. It says proof minus x is equal to x. Modulus of minus x and x. So whenever we put modulus, it may be minus or plus. We get both number as minus and plus. If you find the modulus of minus number also, you get -2. Let's see, -2. Then one will be -2 and the another will be what? -2. Then we get what? -2 and +2, right? We get -2 and +2. So similarly, if we put for +2, right? If we put for +2 also, for the first time, for the first place, here is plus, that's why we get plus, and for the second place, here is minus, right? So we get here minus. So same, right? This is what the question is asking us to prove. So many a time, most of the student could not understand the real meaning of modulus. So you have to try your level best to understand what does it really mean. Whenever we put minus, it is going to give 2 value. Whenever we put plus, it is going to give 2 value. If we put minus also, the value will be same. If we put value, plus also, value will be same, because we are going to take the greater one. Okay, so if we put minus also 2 value, plus also 2 value, don't forget. Alright, next question number 16. Now how we are going to solve this? Now let's see how many terms are here. Here is 1 term, here is 2 term, here is 3 term, and here is 1 term. That means 4 terms, together 4 terms. Or just forget about this. Try ABC, just forget about this. Consider this, 3 terms, 1, 2, 3. So what can I tell you is that this is for 2 marks, okay? So we don't go very lengthy. If it is for 3 marks, then will be a bit long, but it is 2 marks, then we'll go according to the question. So here, this theorem, this question based theorem you will get in your chapter 3. Okay, you will get in your chapter 3. For that, what we are going to do, we are going to split this thrice ABC. I'm going to split this into 3 parts, okay, 3 parts. So let's see here. So let's write the AB, A plus B plus BC, B plus C, and plus CA, that is C plus A plus thrice ABC. Now the solution starts here. What I'm going to do, I'm going to split this into 3 parts, and I'm going to put this every part in every term. Alright, one term each. So AB, A plus B. So I'll divide this one part and I'll put here, okay, A, B, C, plus BC, B plus C, B plus C. I'll divide it again into one part and I'll put here A, B, C. And the last one, CA, C plus A. I'll divide it again and I'll put into A, B, C. Now you are having, I think you are having doubt. Where is this 3ABC gone? 3ABC means 1 here, 2 here, 3 here. 1 plus 1 plus 1. That means 3. 1 plus 1 is 2. 2 plus 1 is 3. Now this is one term and this is one term. Now look at both. What is common? Here is also AB. Here is also AB. So you take out AB, and what will be remaining here? A plus B. You have taken out AB, then will remain what? Plus C. Yes or no? Alright. So next, you consider this to two term, and you see what is common. BC. Here also BC. Then you take out BC, and what is left? B plus C plus A. Right. Now in the next term, you see what is left. Here also CA is common. CA, right? So you take out CA. What will left? CA plus B, right? Yes or no? Now look in everywhere. In everywhere means this is one term, and this is the second term, and this is the third term. Look in 3 terms. A plus B plus C, A plus B plus C, A plus B plus C. Even though what? The position of A, B and C are at different place, but we can see that they have all in common as A plus B plus C. So take out that A plus B plus C as one common term, A plus B plus C. So from here, you have taken out A plus B plus C as common. After you have taken out this A plus B plus C as common, what is remaining here? Here it is remaining AB. Yes or no? What is remaining here? BC, right? And what is remaining here? CA. So this is your answer. This is only for 2 marks. So if you write like this, you will get 2 marks. Don't worry. Right. Okay, question number 17. This is from arithmetic progression. This is the derivation of formula. Okay, Sn equal to n by 2, 2a plus n minus 1 d. So for this, what we are going to do? Let's see. Okay, whenever you are given a question for arithmetic progression, and if the first term and second term is not given or mentioned, then you have to write in your question, let A be the first term and D be the common difference. Alright, you have to mention that. Okay, if you do not mention that, then you have made a great mistake. Alright, do not forget that. So first, let's start. First term and common difference is needed. So let A and D be the first term and common difference and common difference of the AP, and we are going to find what? Sum, right? Sum of n term. Then the sum of n term will be denoted as what? Let Sn be the sum of nth term. Nth term. Then sum means what? Plus, right? Sum means plus. So first, what we are going to do? Sn. Alright, let's say Sn equal to. In arithmetic progression, you have to know that the first term is always denoted by A, Okay, A. After that, the second term is first term plus common difference. Okay, and the third term will be equal to what? First term plus twice of common difference. We'll be going like this. I'm not going to take everything, okay? Just I'm telling you, and you have to make sure that you have already learned the concept of this in your class. After that only you are supposed to see this question, okay, for exam question. Without having this concept, if you learn, then it is going to make you headache. All right, how does it comes? How does? Okay, first you need to learn what is the meaning of first term common difference. Yes, of course, I'm planning to upload the video for particular chapters also, but it is going to take time. But first of all, I would like to make the HSLC questions video, okay? So questions solved video. So the third term, first term, second term, third term, and it is going to go like this, okay? This D will increase one by one, okay? It goes in increasing order. So in which place we are going to end? We are going to end at the last place, and the last place or the last number in maths is always denoted by what? N. Yes or no? So because of that, I'm not going to continue like this. What I'm going to do is that I'm going to put here 3 dot 1 2 3. After that, what I'm going to do, I'm going to put here a plus n minus 1 d. It will be n minus 2d plus a plus n minus 1 d. I'm going to go till here. Now you may be thinking, why I'm taking this. You know, when we learn arithmetic progression, there is a formula, n term. N term is equal to what? A plus n minus 1 d. N term means what? This means the last term. Okay, this means the last term. So last term is this. So last term is denoted by n or L. So last term is this, right? The last term, that is an. An is this. So because of that, the last term is taken as this. So before the last term come, there will be one number smaller than this. That means minus 2 and minus 1. Which is bigger? Minus 1 is bigger, right? Because of that, this comes here. After that, bigger than minus 2. That is this one. This will be greater than this one, right? So that is why I take this at last, right? This is the last term. So I'm going to put this as equation 1. And secondly, what I'm going to do in secondly, I'm going to write everything in reverse order. I'm going to put this first, right? I'm going to put that first. That is a plus n minus 1 d. After that, I'm going to put this. Let me put curly bracket. After that, I'm going to put this. That is a plus n minus 2 d. After that, 3 dots are there. After that, I'm going to put this in reverse order, right? After that, the last one, a, and I'm going to write this as equation 2. Now what I'm going to do, I'm going to add both equation 1 and 2, and I will see what I get. Adding what? Equation 1 and 2, we get what we get. Let's see. Sn plus Sn becomes 2Sn. I hope you will not mind, right? After that, we are going to add the term which are straight to one another. This and this is to be added. This and this to be added. This and this to be added. This and this to be added. Okay, the straight one. All right. Now let's see. When we add these two, what we get? A plus A is 2A. Yes or no? 2A. All right. After that, nothing is left. But here we get this. So we'll put n minus 1 d. Okay. So okay, one term plus. Now let's add these two. here you are going to get confused, right? This is the place where you are going to get confused. So let's see here what we get. I'm going to add up here and I'm going to show you. After that I'll wrap it. So this is a plus d, and the another one is, we're going to add, right? So I'll put here plus. Another one is a plus n minus 2 d. What we get? Let's take out this. So let's open the bracket. A plus d plus a. These two multiply, we get what? Nd. These two minus plus minus 2 into d, 2d. Now a and a, we get 2a. Yes or no? A and a, we get 2a. After that, let's write nd. This is plus d and this is minus d. We're going to minus. So minus 2 plus 1, we get what? Minus is bigger, right? So minus, we'll get minus. 2 minus 1 is d. Yes or no? Then what we get? 2a plus. What is common in this? D is common, right? If I take out d, n minus 1d, it will remain like this only. D into 1d, d into n, dn or nd. So what I get here is just like this. Same all around. Is it same? Yes, right. So I'll put this here. So you have already known how this has arrived, right? I've already calculated here. If you have any confusion, just see this. You will understand that. Okay? This term and this term. Alright, so let me rub that. Where's the wiper? Let me rub that. This part should be rubbed. That was just to explain you. Okay, then I can just write this. Just now we have seen the value, right? N minus 1d plus dot 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 plus. Now this and this is equal to this and this. Yes or no? So if we sum up that, we'll get exactly what we get just now, right? So I'll put here directly the answer 1, 2a plus n minus 1d plus. Now again this and this, just like this and this, so we get the same answer, 2a plus n minus, okay, it's not making nice. So I'll put here again 2a plus n minus 1d. Alright, so we are going this till how many times? Till n times. Okay, we are going till n times. So n times, we are going till n times. If we are going till n times, then what will happen? This n is going to multiply at front. Okay, because we are going till n times. Okay, this is n. So next step, 2Sn, this n will come here because we are going till n times. And here what do we see? We see all the numbers, all the values are same. Then you take 1 as a common, 2a plus n minus 1d. After that, 2Sn means 2 into Sn. Into goes other side becomes divide. So you keep here Sn equal to what? N. This is into goes this side becomes divide. And what do you get? 2a plus n minus 1d. So this is your answer. Hope you understood. If you have any doubt, please comment in the given comment section, so that I may help you to clear your doubt in a better way. Okay, question number 18. It is also from chapter 6. The nth term of a sequence is given by n equal to 3n plus 2. Show that the sequence is an AP. Alright, so for that, what I like to make you understand is that whenever a given sequence is in AP, then we have to see that this term and the next to this term, that is, this is an term, right? An term. Next to this term will be an plus 1, right? If these two values when subtracted, if you get a constant number, okay, that is a number, maybe 5, maybe 6, maybe 3, 1, 2, 3, whatever it may be. If you get a number, okay, then we consider that the given sequence is an AP. If not, that wouldn't be AP. Alright, so I'm going to write here AN is given to be what? 3n plus 2. Right, 3n plus 2. So for that there are many methods to do this. I'll solve here in two methods. First this is the method. Let's see. Then what we need to do is that after taking this, we're going to find another, that is an plus 1. Now wherever there is n, you are going to put n plus 1. Okay, then what we get? 3n plus 1 plus 2. Alright, in place of n we are putting n plus 1, because here it was n and here it is n plus 1. Now let's see, 3 into n, 3n plus is plus, 3 times 1 is 3 plus 2. What do we get? 3n plus 5. Right, we get 3n plus 5. Now we are going to subtract these two. When you subtract these two, if we get a constant term, that is a number, then it is a AP. Okay, now an plus 1 minus an, what do we get? Let's see. An plus 1 is this, right? So 3n plus 1 minus, that is an, right? So an is what? 3n plus 2. So what do we get? 3, no, wait. An plus 1 is 5. Sorry. 3n plus 5. Sorry. 3n plus 5. Plus minus is minus. 3 into n is 3n, right? Plus minus 2. Yes or no? So what do we get? 3n and 3n cancel. 1 is plus, 1 is minus. So we have 5 minus 2, which is equal to 3, which is constant, right? Which is constant. Which is constant. Alright, constant. So my marker is also about to finish, it seems. So which is constant? If we get like this, then we call that as constant. So therefore the given sequence is an AP which is constant. Therefore the given sequence is an AP with common difference. What? Common difference. The last one will be your common difference, with common difference 3. So this was your answer for question number 18. So we can solve this in another way also, but according to your textbook, it is being recommended in this way. Okay, so because of that I am solving it in this way. Alright, so first n term is given. After that we are going to find an plus 1 and we are going to subtract. Okay, and if we get constant term, that is a number, then we get the correct answer. Alright, we get the correct answer, or that is a AP. If not, it is not an AP. If it was here 3n, then it is not AP. Alright, so if we get number like this, then it is always AP. Okay guys, this is the last question for 2 marks. Okay, so 2 marks, this is the last question, and this question is from circle. Okay, circle. The length of a tangent to a circle from a point which is at a distance of 5 cm from the center of circle is 4 cm. The length of the tangent. Okay, the length of the tangent. So first of all, let us draw a circle. Okay, we need to draw a circle. Right, we need to draw a circle. After let's take this center as O. Center of the circle is O. Then what is the question? The length of a tangent to a circle from a point which is at a distance of what? 5 cm from the center of the circle is 4 cm. Okay, so from the center there is one point here. Let's say here. Okay, here. Let's say this is point P. After that, this P is what? This point P is at a distance of 5 centimeter, at a distance of 5 centimeter. And from this point, there is a tangent, okay, there is a tangent. Let's say tangent is this. Let's say this is the tangent. Let's say this is the tangent is not becoming okay. So whatever. So this is a tangent, and the length of this tangent is what? The length of this tangent is 4 centimeter according to the question. So let's say this is the tangent. So we have to find what? We have to find the radius of the circle. So radius will be this OA. OA will be the radius, right? OA will be the radius. So we have to find that. So let me write here. Let OA be the length of the radius of the circle, and PA represent what? Represent the tangent. Such that let's describe what are the things given. PA is equal to 4 centimeter, correct? PO is equal to 5 centimeter. Now we have to know that, or we have already known, I should say we have already known, because this, I hope this video, you are coming to see this video after you have learned the chapter, because this is for HSLC, right? So the place where tangent and radius meet together, it is going to form how many? 90 degree angle, okay? 90 degree right angle. So we can apply Pythagoras theorem in this problem. So I can say like this. Now in right triangle, where is your right angle? A, right? So the A should be in the center. POA, okay? PAO. A is at right angle. In right triangle, POA by Pythagoras theorem. Theorem. So the hypotenuse, which will be your hypotenuse? The side which is opposite to the 90 degree. Okay, this is 90 degrees, so opposite is hypotenuse. PO square is equal to what? PA square plus OA square. What is the value of PO? PO is given as 5 square. PA is 4 square. OA is, we are finding out. Let's see. What is the value of 5 square? 25. What is the value of 4 square? 16. Right. OA square. So 25. This is plus, comes this side becomes minus 16 is equal to OA square. So 25 minus 16. Of course it is 9, right? Square come this side becomes root over OA. We don't need to put here plus minus, it will be always plus, because we are finding the length of something. So length will be always positive, it can't be negative, right? Distance will be always positive. So now let's see. OA is equal to what? What is the square root of 9? Square root of 9 is 3 centimeter. So the radius is 3 centimeter. Therefore, length of the radius equals to 3 centimeter. I hope you understood what I mean to say. If you have any doubt, like I have said earlier, feel free to ask me, comment me. I'm going to clear your doubt again. This is the end of 2 marks question. So 13 1 marks question. After that, after 13, I think 5 2 marks question, right? 13, 14, 15, 16, 17, 18, 19. Okay, 6. So we have completed 2 marks question. Now will be followed by 3 marks.